Welcome back everyone to the theCUBE studios here at the New York Stock Exchange. It's the theCUBE East Coast studio, partnering with the NYSE Wired community. This is our Wired program. Of course, the AI Factories is an ongoing series. We feature leaders in large-scale infrastructure. Obviously, supercomputing is now the data center. Data centers connect to each other. They form more compute power. This is the key trend that is really fueling a generational shift. We've kind of been seeing it coming, but it's now hitting mainstream. Infrastructure is the key investment and enable area. We've got a guest here, friend of theCUBE, going back before founding of theCUBE, actually. Jason Hoffman, Chief Strategist of Switch. Really early days on a lot of technology, cloud, former co-founder of Joyent, well-documented company that essentially brought in the era of DevOps, part of the, what they call clouderati. Gone on to do many, many things. Jason, we need you to come in and help explain to the real world what these AI factories are. First of all, great to see you. Thanks for coming in.
Yeah.
Nice rig you got going there. Thanks for coming in.
Thanks for having me, John. I really appreciate it. And yeah, that's you know, as Wired described me, I'm the creator of Cloud's Baymax. So it's something.
Yeah, you know, pioneers take the bullets, but you know, early days, remember those days in 2008, you know, the meetups in the early days, a lot's changed, but now the AI factories are here. It seems like a similar movie where the data gravity is, data centers, Switch, big part of that. Remember when you guys were formed? Now more than ever, data centers are in demand, but unpack this AI factory kind of large scale computing trend. You got the big build outs, but then you got the enterprises trying to figure out how to do AI when they've had cloud or on-premises activities. What does an AI factory in your mind mean for the industry?
Oh yeah, that's a great question. I mean, in the case of Switch, we've pioneered a certain data center design, you know, which is largely the encapsulated hot aisles that go up to a plenum roof and going up to, you know, a pretty good scale density on a per rack basis in there. And that's been the history of the company for the last 25 years. As you know, Rob Roy's still the CEO of the company. He's the founder of the company in there. And I'd say that in the previous generation, a lot of the conversation around data centers, the building itself was part of the overall design. And you would go and put, you know, data centers. You'd go and put servers inside of the data centers, and then, you know, sort of call it a day. You know, it was in a lot of ways a hotel business for, you know, these type of compute elements and the like. In the case of an AI factory, it's a lot of what's in the name. The internals of the building start mattering quite a bit. And they start mattering quite a bit because of the shift of the kind of equipment that goes into them. You know, when we sort of kicked off computing 50 years ago, it was a lot of scientific computing and these big sort of vertically scaled systems. And we've always had these kinds of like supercomputers that are, you know, present in scientific computing and other sort of areas in there. And then, you know, what sort of kicked off in parallel to that was, you know, the use of mainframes and personal computers and cloud and, you know, everything that's sort of being used in the enterprise space in there. And then with AI taking the whole swing back, what we're really seeing is that kind of commoditization of these supercomputers. So things that need to vertically scale, not sort of scale out, you know, in a lot of places like what we have with cloud and enterprise. And so on these AI things, the more dense these racks can be, the better. And we're seeing these kinds of fun densities, like going from an industry average of 20 kW to 2 megawatts, you know, sort of per rack from a, you know, roadmap perspective. And it means that all of a sudden the internals of these buildings become almost like the internals of a semiconductor fab, you know, which we don't even talk about the shell of a semiconductor fab. We talk about the internals and the machinery that's in there and the building of the chips. Yeah. And so in a lot of ways for the data center industry, as it sort of shifts into this kind of factory mode, it's really about the internals and what goes inside of it and a totally different set of metrics and everything.
You know, I'm really glad to do this interview with you because I remember the pioneering days when you guys started Switch. And we covered, I think they called it SUPERNAP or something. Is that still around, that name, or was an early name?
Yeah.
Love the word super cloud, SUPERNAP. I mean, at that point, that was pioneering. I mean, like, you guys were early. What were some of the learnings that you could look back now and say what Switch did? Obviously, smart to think about it that way as a self-contained system. It's a systems design. Systems thinking is now kind of new. It's a nouveau thing. You guys have been doing it for a while. So as companies figure out, one, who they partner with for, say, large-scale supercomputing building / system, as well as maybe an existing data center that might not have a power envelope that could be designed around it. I mean, it's bounded by power on the smaller, well, small, regular data centers. But then how do I evaluate this? Take us through what you've learned at Switch, what the learnings were, because you guys had to do that module design. You thought about the big picture, and you had to deal with the power, you had to deal with the density, you had to look at the substrate of the building. How do I get more copper? I mean, all these things are now being talked about mainstream.
Yeah, I mean, what was super clear for us is one of the, I mean, like when the NVIDIA H100 systems came out, you know, like meaning the equivalent of what sort of a chat, you know, like a GPT 2, 2.5, 3, these kind of things were trained on. You know, we housed, you know, what was one of the first large clusters of that. So roughly about, you know, 7,000, you know, H100 systems inside of there. And it was all air cooled, you know, because we could do those kinds of densities in there. You know, and Switch had this design, you know, which has become the industry standard now of, you know, here's a building and air handlers are outside and, you know, everything exits out to a plenum and goes out to these external air handlers. And, you know, it's just this whole idea that, you know, let's go ahead and, you know, build a 100 megawatt sized, you know, facility, you know, 17, 18 years ago, you know, which, you know, was 18 years ago was sort of crazy that you'd go build a building that size. And as you mentioned, the first of the SUPERNAPs, Las Vegas 7, was exactly that kind of 100 megawatt, you know, size like facility. And so when we went and looked at these first kind of air cooled cluster deployments, you know, it was very clear that
it won't last long.
Yeah, the sort of balancing the, you know, it's very difficult to, you know, as you sort of go to these higher densities and you deploy more power, you can strand space. And if you want to fill up the space, then you're basically not building a cluster as compact as you can be and so on like that. So it was clear to us a couple years ago, you know, pretty, you know, soon after sort of like the first, you know, ChatGPT, you know, took off. So we're really talking the first half of 2023, that we would have to, you know, basically introduce liquid cooling into it. And so the design that Rob came up with was taking the air handlers that are outside that were sort of in the megawatt range, minimizing them down, and then, you know, sort of going from this like macroclimate perspective to a microclimate perspective. And we started sort of encapsulating, you know, each and every rack, you know, inside of its own, you know, effectively like refrigerator. As we brought those air handlers inside, it meant we actually brought those kind of like, you know, liquid and plumbing inside of it and, you know, everything else and all the supporting structures to do that. And so we started thinking that what we really had to develop at Switch was this, you know, sort of an equivalent type of system roadmap that would line up with an NVIDIA system roadmap that would line up with like a TSMC semiconductor process node and packaging kind of roadmap. That just like how you sort of have these nanometers flow up here and you have sort of the packaging that comes up into it and it comes up into these system sizes. In some ways, there's sort of this first era of systems that are now showing up that are sort of the 150 to 300 kW, you know, size. There's going to be sort of the second era that's, you know, 600, 700 kW. And sort of this third era that's like a megawatt plus type rack. And the technical challenge that, you know, we gave ourselves, you know, a couple years ago then was to figure out like, how do we go and design for a 2 megawatt per rack kind of future, but do it in a way that, you know, minimizes the number of parts and makes it relatively straightforward to, you know, still sort of like manufacture. It gives us a lot of optionality, you know, because we don't know exactly how these clusters are going to work out or the like. And so, you know, Rob came up with his Evo design, you know, that's now been, you know, where like the world first GB200s and GB300s and B100s were deployed, you know, in our design in that. And we have these concepts largely of like what you think of a density node, where it's a known amount of cooling and, you know, power delivery in it. And then these sort of cluster packages where we have known, you know, sort of our own sort of abstractions around, you know, what a cluster topology is going to look like, because not everything in there is liquid cooled right now. And there's still networking and storage and the like, and so on. And so we just managed to come up with a design that, you know, flows from a TSMC type of roadmap, flows into an NVIDIA system roadmap, flows into a long-term sort of 20-year design of our facility roadmaps in it. And
It's interesting. It's
took that approach.
You know, what's interesting is first of all, I love hearing you talk about this because the systems thinking is a new thing, right? I mean, at the large scale, you guys are just pioneering. You're doing it. What's interesting is that back in the old days, remember the old drop ship me a server, and we'd load Linux on it or something, actually load software on it. I mean, people want drop shipped data centers as supercomputers. I mean, so when you talk about a density node, what pops in my head is, okay, I might have a power constraint or I have a location. I need a fully encapsulated system that just plugs in. I mean, that's like a boatload of servers, some network fabric, full stack, all those things have to be built in. It kind of sounds a little bit like, you know, just drop shipping a machine. I remember Amazon came out with, what was it called, Outposts? Remember those days? They had that concept of just having, you know, replica of a cloud. We're kind of seeing what you guys are doing and seeing, okay, the edge is going to get smarter. There'll be some form factor. Maybe some may be bigger, maybe the size of a old telco box at the side of the road, or the size of a camera on a pole, where training and inference will have to happen. So as you look at that distributed computing paradigm expanding, what do you guys see as the practitioner angle? Because you have infrastructure people. There's not a lot of talent out there. I mean, they claim there's IT talent, but that's IT. That's not system design like what you guys do. Then you got like the chief AI officers out there going, let's go get some Gen AI. So, you know, give me some magic dust and build me some CapEx. Like, not that easy. So, like, take me through how you see the evolution here, because it's going to get distributed. There'll be big mega centers, SUPERNAPs, and then there'll be like mediums, and then smalls, density nodes, whatever you call it.
Yeah,
so take me through that.
Yeah, the question really is like, what is small, and is small really achievable? You know, in that kind of sense. You know, and I say this again as somebody who's done a cloud computing company. I did an edge computing company that Google acquired. Now we're sort of building these large scale AI factories. You know, I built mobile networks. You've done a lot. That's why I asked. Yeah. So like in the case of you know, having worked on 4G and 5G and the sort of overall architecture of it, I mean, I would say that the comparable CapEx from what's being deployed right now from an AI perspective was really done building out 4G and 5G networks. You know, meaning the deployment of 5G networks and sort of going into LTE advanced globally was, you know, spending like on the order of, you know, $1.25–1.5 trillion, you know, to sort of go deploy that across every country on the planet. We see sort of a similar thing like on the more non-technical side of it that occurred over decades was the deployment of air conditioning and refrigeration globally. You know, that's roughly about 220 gigawatts of things. In the US, it's about sort of 80 gigawatts, if you will. If you look at the AI footprint that people are building into the US, they're building into a footprint that's about the size of air conditioning and refrigeration, right? And so, meaning that's air conditioning and refrigeration is why the grid was really built out post World War II, you know, in a lot of spots in sort of the world. You know, these kind of build outs, I think, are people sort of underestimate the size of them in a lot of ways and what's sort of required of it. And we'll get down to the distributed part of there. I mean, like in the case of Switch, you know, we're headquartered in Nevada, and we have a very large footprint in Nevada. You know, as we continue building out that footprint, you know, because like in Nevada, we also can function as a behind the meter, you know, unregulated utility and the like in there. I mean, I think fully built out in Nevada, you know, we're something like a third of Southern Nevada's power, 2/3 of Northern Nevada's power, and we have a total power footprint that's like the equivalent of Los Angeles. And so if you think about like what it takes to go and build total infrastructure like that.
So you're comparing it to like the 4G, 5G build out CapEx equivalent, but at data center scale.
I mean, it's the kind of thing where like these AI campuses we're developing are, right now a top 10 industrial site historically. And then I think as we start making them even more dense,
Yeah, yeah.
over the next like 5 to 10 years, they'll surpass anything that we ever saw from large scale oil fields, refineries, smelters, sort of a number of things like that. There are, in the US, for example, outside of like a Gulf-based refinery site, so on like that. If you go and you look in various states, the AI workloads are the largest industrial always on
Yeah.
power, site that's basically sitting in those kind of areas right now.
Yeah.
And so when you start thinking about minimizing those, the question always about how much is required in sort of the middle mile, if you will,
Mm-hmm.
is going to come down to how powerful, a device like this is,
Yeah.
and then how powerful the centralized compute is going to be. And so, in even the sort of quote unquote edge conversations and where inference is going to live, I would say that it's going to live on the device, and it's going to live in very centralized data centers. The things that are in between are still going to stay relatively lightweight, because if right now it's already a challenge to get 700 800 kilowatts into sort of a tower, around sort of
Yeah.
base stations being present there. We're not going to be able to stick like a 2 megawatt rack at the bottom of that tower, or do that kind of thing. These density around these systems, are technically very challenging to go and distribute. I mean, a single rack has the same power footprint as most traditional enterprise data centers have in total. And so a lot of people have a 4 megawatt or 8 megawatt data center. Well, that's just 4 racks in the future, of some of this gear. So how exactly is that going to work in a very like distributed footprint?
Yeah.
And so increasingly, it's like a lot of the inference ends up happening on the device and ends up happening in very centralized data centers.
Mm-hmm.
It ends up following, I think, a lot of the same curves that you see in gaming and sort of other stuff. You have a very powerful PC and then very centralized sort of computing, sort of doing these types of like stadia in the middle is just not something that economically penciled out over time.
Explains why Texas likes the AI. They love their oil too, as you said. It's like oil fields down there. I love that point, because I think, to me, right now at the edge, inference is high. Oh yeah, it can infer at the edge. Makes a lot of sense. But training is coming in. Edge devices get new data all the time, right? So this comes back down to your point about the architecture of the middle mile or distributed nature of the mega centers, which I do buy that with you. I would see that happening.
Well, if you look at the largest footprint of neural processors, it's on device.
Yeah.
It's not in a base station or in an old central office or in a sort of, regional data center and the like. And the most of the experience around these things is such that, you're typing into like a chat GPT and it's printing out. It's not something that has to occur within 10 milliseconds, or 20 milliseconds or that type.
Well, talk about networking. Obviously, you have a networking background as well. Obviously, a switch is highly interconnected. Interconnects are the new thing. Jensen Huang was on stage last year at GDC, and he said, KV Cache is the operating system for the AI factory. And I'm like, oh, he said it. Someone finally said. I've been saying on theCUBE, what runs on an AI factory? What OS? What is the OS? Like in the very elementary computer science definition. You got an operating system, it does a function. It runs hardware and it makes stuff work. I'm oversimplifying, obviously, but the question is, what is the OS for these clusters, these large-scale AI factories? And it's interesting, he said that, and I'm like, oh, it's networking, because that's what brings systems together. So, what's your reaction to that, and is networking the OS of the AI factory? Or memory?
Well,
everything?
No, but I'd say that, in general, and it goes to like a AI factory, even if we anchor it in traditional data center metrics like PUE or sort of other things in there, for it's going to come down fundamentally to token per watt. And then if you basically go to the next sort of thing of like, okay, we have these systems that are sitting there. A data center is responsible at the end of the day for powering and cooling, say, a given rack of these systems. And we're trying to accomplish a certain token volume per watt, token output per watt. Okay, when you start looking at these sort of data packets through a network stack, then on the model layer, you're trying to accomplish like sort of token flow through these attention blocks. When you go into the data center analogy and you think of like virtual memory management and paging and putting things in and out of a register, which is what typically an operating system does. So if you think of what an operating system normally does, is it boots up a piece of hardware and it's fundamentally doing virtual memory management and taking things in and out of there, putting things on and off the CPU.
Yeah.
Well, you would say that a model layer equivalent to that is KV, cache allocation and eviction. You could absolutely say that. And then when you look at sort of operating system address space expansion and what sort of occurs there, that would be like context window extensions present inside of a model.
Yeah.
When you start thinking about distributed operating system kernels, that would be like the sort of multi-node sort of cache sharding and those kinds of things that you'd see in these models. And then these sort of like long-lived processes with stateful context and stuff starts being these kind of streaming, inference that you get with sort of persistent key value stores and that types of things. And so I'd say that
I think you just summarized it beautifully. I think one of the things I was talking I want to get your thoughts on the I used to call it the holy trinity of computing: storage, networking, and compute. But I would add a fourth pillar in there: database. Database is now key part. You mentioned key value store. The role of the database isn't just the software abstraction now; it's actually part of the data piece of the networking, storage, and compute. It's almost a fourth pillar of that OS dynamic you mentioned. I mean, some of the things there, but this is distributed computing in the modern era. This is the science behind that, and this is what people are trying to figure out. What is the ideal science for that environment, and then how do you optimize it, design, optimize, run? Any reaction to that? Any thoughts?
No, I mean, I think databases at the end of the day sit on top of storage. It's sort of in there. It's just another, sort of abstraction layer. I mean, a key value cache is technically a type of database that's in that. And so the analogies on these hold. I mean, I'd say that like in the case of AI, the sort of vector databases are particularly important, of course, for keeping state, and then these retrieval caches and feature stores and other things that are in there. These are
subsystems.
Essentially, the semantic memory of these kinds of systems. They actually give a model any sort of persistence of knowledge, grounding, recall, anything beyond the sort of weights of the model. And so if you sort of go from this kind of like weights only model you're interacting with that sort of knows nothing and you need to start using it from an enterprise perspective, then it's where that sort of knowledge sits.
All right, let's talk about Switch. You're the chief strategy officer, by the way. You have a great pedigree of experience. As you talk to customers, what are some of the things you guys are doing that you would say illustrates kind of where the wave is right now? I mean, obviously, you got the data centers, the super centers, SUPERNAPs, but you also there's a business where you guys are actually deploying on behalf of customers too. To run operations, is that part of it? Like, where are you getting pulled into? What does your 3D chessboard look like?
Yeah. I mean, it's like, Switch is unique in the data center space in that we design, build, and operate large-scale campuses where enterprises can come and get the benefit of a scale that would be very difficult for any enterprise to get. And campuses that are large enough that even hyperscalers go, oh, we could build a region there. So for us, when we talk about exascale campuses, these are things that are typically designed to start out in the 3 to 4 gigawatt type of range and are capable of scaling, beyond that. And where we can go and do, literally terraforming, utility development, build out the network, sort of do everything that's in there. And so we function a lot like the nuclear powered aircraft carrier of the data center space is sort of how we think of us from sort of the fleet in that. And then, I would say that, we are founder run. Our founder is a very good structural, mechanical, electrical engineer, and has been doing that in the data center space for the last 26 years.
Yeah.
We've gone and added a lot to the team of like myself and others that are experts in distributed systems and software and bringing new sensors and so on, sort of like that.
Yeah.
And so a lot of what we've been doing is how do we go and digitize all of these types of things, our own design process, the construction process, those sorts of things in there. How do we do a lot of prefabrication and manufacturing beforehand? How do we introduce a lot of optionality? How do we make this more modular? And so what we function with in sort of our largest partners is it is our job to go ahead and have a very like future-proof long-term roadmap and design around what we're doing there, and making sure that those are aligned with folks like Dell that are doing, the sort of total systems, people like NVIDIA, even sort of the semiconductor manufacturers and people that are sort of going and doing that, and making sure that if somebody goes and deploys these kind of leading edge systems right now, that they'll still continue doing that in our facilities 10, 15, 20 years from now, just like has been the case historically.
Yeah.
And so we try to be that exceptionally knowledgeable design partner. Yeah. And people that are then capable of building and operating and having those things continuously flow together.
I just had Michael Dell on. He'd be pleased to hear that. I mean, you guys are like a colo on the nuclear powered aircraft carrier. Can I have some of that?
Well, our Austin campus is on. Yeah, that's part of his old campus. So our data centers are nestled within those buildings. Yeah. Yeah. Sort of in there, and we're. Dell is who we get our own GPU systems from.
Yeah, Dell's kicking ass, and he said on theCUBE that they deliver the goods and that's maxed out immediately. So you're seeing the demand cycle heavily. Your interesting view on the campus, I think that's like almost a real estate play. And look at data centers that started as real estate investment trusts. Now they're full on supercomputing. So you can almost see the dots connecting as you lay that out. Large campuses have optionality if they have power and utility. Why not turn that into a factory?
Yeah, and we do this thing where I mean, I would say that go ahead and be maybe a tad arrogant for a moment, but like we're probably the most advanced user of NVIDIA's Omniverse and sort of digital twin efforts that are there. We have some of the largest models that have ever been done in that system, and we sort of look at how we've gone and digitized aspects of the power chain and so on in there. My goal is to really go and support, Rob and the broader team, so that when we engage with our customers, we can basically take our team and put it together with any sort of technical infrastructure team in any company in the world, and basically, be a credible technology partner.
I mean, you guys are so smart. I mean, you guys been following, obviously Switch from the beginning. Remember when you first got the high bandwidth there? I think we got a tour in Vegas early on. You guys are thinking like material scientists as well as not just computer scientists. It's a lot of engineering.
Yeah.
And the upside is potential's huge, because now you are solving the problems. Now, NVIDIA's Omniverse is interesting because you're getting real data. They're trying to supplement with synthetic data. You're a huge advantage for NVIDIA's Omniverse. You're pulling in massive data, and your digital twin.
Yeah, no, absolutely, yeah. Well, and it means too that like our own compute sophistication and footprint and our own deployment of these GPU systems internally for our entire design chain, how these things get commissioned, how they're sort of operated on a go-forward basis. How do we do everything from sort of capacity, reliability to so on. Mm-hmm. Has become really using every possible modern tool that one can use. So.
Well, Jason, great to catch up with you. I'm so glad we connected. Definitely want to follow up with you and put you on the roster for heading you back up, because one, the work you guys are doing there, what you've done, your unique experience, you're seeing all the theaters that you've done. Body of work in your career, telecom, networking, cloud, switch now. So like, you got a unique perspective. So we really appreciate you spending the time with us here in theCUBE and the NYSE Wired community. And of course, we're in our New York studio, and NVIDIA stock price is looking good. Or Tesla.
Oh, no, thank you NVIDIA for being up 16.8x since 2020. My only portfolio regret is you weren't 100% of it.
Absolutely, everyone's feeling good. It's a great wave right now. It's almost like, you know, for us as we look at this next generation, it's a generational moment. It really is. Just your thoughts on that as you look at the industry right now. It's like, wow, this is highly accelerated, road to super intelligence, whatever you want to call it.
Yeah. Well, it's a part of a continuation in many ways. I mean, if we go and we think of, it just depends on how far back do you want to go. I mean, if we go all the way back to literally the printing press and the first Gutenberg Bible and the Reformation, well, large language models are a distillation of language themselves. It's interacting with language. And so, and, you know, utilizing that in sort of different ways. So you can think of it as maybe the culmination of the last 500 years, you know, of sort of technology efforts or the like. But I think for me, you know, look, as you and I first met, you know, 20 years ago, as cloud was basically kicking off, when cloud was taking off as a trend, it wasn't like something that impacted the world's largest companies. So recall back then, the world's largest companies were oil and gas. I mean, you had like, you know, you had telcos in the top 10, you know, that kind of thing.
Yeah.
And then when the iPhone comes out and mobile phones come out and you start getting social media on mobile phones, you know, the sort of effort there around mobile, it's like, yeah, mobile impacted consumers and you had the consumerization of the enterprise and so on like that. But now we literally have, in the case of AI, we have a technology, you know, sort of currents, or, you know, however we want to call it, but we basically have a thing going on right now that directly impacts the world's largest companies.
Yeah.
And, you know, so what we're sort of seeing is honestly something we haven't seen before in that, you know, because you have sort of like, hey, these are the top 10 or 15 companies in the world. And then this is a new technology it's potentially disruptive for them. It's also the biggest opportunity they've ever had.
They could win too.
So,
they focus on it.
And so everyone's going. You know, that was not the case with mobile networks. It was not the case with cloud when it rolled up. It was not the case with, you know, even sort of like the PC. Yeah. You know, it didn't have this type of thing of like, oh, you know, we must do this in order to there. And so you're seeing an unprecedented amount of money being spent. Yeah.
And the intellectual capital. I mean, I've observed that on that same note where the generations of old and young are interacting. It's not like the young beat the old. There's so much, because it impacts everyone. It's the connections. Everyone's in. Everyone's in the game from day one.
No, and you know, again, like in being here in the Bay Area where I live in Los Gatos, it's like we got a Google head of something that lives on the corner, and another one sort of there, and another one sort of there, and so, you know, the local barbecues, if you will, include old and young and sort of this and that, but it's all from all the places you'd think, and it is an area of you know, just sort of like a tremendous intellectual interest right now.
It's a positive interaction and relationship. Jason, thank you so much for coming on theCUBE again. Great to see you, CUBE alumni, many times on. Really appreciate your friendship, and thanks for taking the time.
Thanks for having me.
All right, cool. I'm John Furrier here at the New York Stock Exchange CUBE Studios, part of our NYSE Wired program. Of course, we got our Palo Alto studios, so we go to all the events. As AI goes mainstream, it affects the entire society at large, the planet, and even in space. This data center is going to be in space soon. Who knows? Thanks for watching. We're doing our part to bring you the linguistics and the data. Thanks for watching.